Hello, greetings. In this video, we'll be discussing probability. But before we begin, I just want to encourage you to visit our Facebook page at this URL address. And do not forget to like the page, share it, and comment on the page. And do ask us some questions that you would like us to create a video tutorial or any maybe paper solution on. If we do have time, we will surely do assist you on that. So let us begin with today's session. So today I'm going to discuss the basics of probability. I know that some of you did not get to do these topics at school. So I'm just trying to summarize it quickly before we do some real problems. So given any two events A and B that belong in the sample space S, sample space is nothing but the set that contains all possible outcomes. So sample space is the set that contains all possible outcomes. So do not be shocked or be scared of what we mean by S. We just mean that big set that contains all the possible outcomes. So suppose that A and B are also found in that set that contains all the possible outcomes. In other words, A and B must also be some of the outcomes that you would expect when you perform a certain experiment. So we have, if you're given two events A and B, we have these two ways of thinking about it. We say the probability of A union B, this sign can also be written as or, it means or. So you can read it as A or B is always going to be equal to the probability of A plus the probability of B minus the probability of A intersection B. This also can be written in simple English to mean and. So again, do not be scared of these symbols. This one means or and that one means and. So in that case, when you're given a situation where you find that these events are mutually inclusive, then we say that we use this formula, which is called the probability identity. So this is the formula that is used a lot. So if you are asked to verify that events are mutually inclusive or not, then you would use this formula and you would make sure that the probability of A or B equals this side here. So what we mean by mutually inclusive events, these are events that can occur at the same time. These events can occur at the same time or simultaneously. So they can occur at the same time. So that's what we mean by mutually inclusive events. So again, do not be alarmed or scared of these new terms. Again, by mutually inclusive events, we mean events that can occur at the same time. So if they can occur at the same time, then we use this formula that is called the probability identity. But what I want us to do right now here, I want us to think geometrically, what does this mean? What I mean by geometrically, I mean if you're asked to draw a Venn diagram for a situation like this. So again, suppose that you are given some event A. So I would draw an A there, and then I would also have some event called B. So this is B. So the probability here, this is the intersection. So I would label this to mean that means the probability of A and B. So this point here, this portion here, means that the probability of A and B, and the entire portion here means the probability of A. And then you need to be careful, grade 10s. This means the probability of A only, and this part here means the probability of B only. So you must be careful when you're trying to analyze the Venn diagram. And again, the entire circle here means the probability of B. And then if you had to account for some people that are out here or some numbers that are outside here, these are people that do not take part in this survey, or we would label it as follows. This is the probability of not A or B. So this is how we would label these people here. So I want you to always associate this diagram with this formula. So whenever you think about mutually inclusive events, then that means there will be the point here, which is called the intersection or the probability of A and B, and the Venn diagram would always look like that. Now let's move on a little bit and discuss mutually exclusive events. Mutually exclusive events, as the word says, exclusive, it means events that these cannot happen, they cannot happen at the same time. They cannot happen at the same time. So these events cannot happen at the same time. So for example, you cannot say you've passed and failed mathematics at the same time. So the event of passing mathematics and failing mathematics are just completely mutually exclusive. Only one event can happen at any time. So that event is described as mutually exclusive events. So in other words, there will be no commonality between those two events. So there is no intersection. So this is extremely important, greatens, to remember that for mutually exclusive events, the intersection, the probability of A and B will always be 0. So please note that the difference between this formula and that formula is that you don't have this part for mutually exclusive events. And do not forget this. Please also make sure that you don't flip around this sign. Please also, again, do not be scared. This can also be written in English to mean A or B. So please, again, please do note that you do not have that the intersection here on this part for this formula. So that's what we mean by mutually exclusive event. Again, maybe it would be helpful for us to think about how would this look like when it comes to the geometry. So again, here, since there is absolutely no relationship between these two events, then that means there will be no point of intersection. So you are going to have two pictures like that, the probability of A and B, and there will be absolutely no relationship between these two events. So this will just be the probability of A, and this will just be the probability of B. So the sum of those two probabilities will give you the probability of A or B. Again, before I forget, grade 10s, I just want to assist you with one thing here. If you're asked to determine from the Venn diagram the probability of A or B, then you are expected to look at all these numbers here. Suppose this number was X, and this one was Y, and this one was Z. So if they want you to figure out the probability of A or B, then that means it's going to be given by X plus Y plus Z. So that is extremely important for you to remember, that you would have to consider all these three numbers. Therefore, do not make a mistake or be stressed about what we mean by the probability of A or B. So please think about that carefully. And then now let's just try to discuss the last part on this part 1 video. Let's discuss the complementary events. Complementary events are in a way mutually exclusive events in that they also cannot happen at the same time. But what we want to emphasize here is that the sum of those two probabilities is known exactly what it's going to be equal to. The sum of those two probabilities of A and B is always going to be 1. For example, if you are tossing a coin, the probability that you will get a head will always be a half, and the probability that you're going to get a tail will always be a half. So the sum of the probabilities, the probability of A plus the probability of getting a head plus the probability of getting a tail will be a half plus a half, which is 1, which means the probabilities of tossing a coin, the probability of tossing a coin is not just mutually exclusive, but it's complementary. In other words, only one event at any experiment is guaranteed to happen. So we are assuming that if I'm tossing a coin, I know exactly that in each experiment or in each trial, I am expected to get either a head or a tail, and the probability will always be half in each case, and the sum will always be 1. So what we also do here is to define what is called a complement. If you give me the probability of A, we say the complement of A will be A prime A. Again, grade 10s, different textbooks and different study guides and different teachers use different notations to denote the probability of not A. So what this means, it means nothing but not A. So it can be denoted as follows. You can just have an A with a hat on top. But in most cases, the exam papers like this one. So why I use this one here. So the probability of getting A is always going to be equals to 1 minus the probability of not getting A. So if you don't want to write this, you can just simply write not A. So the probability of getting A will be 1 minus the probability of not getting A, which is also the same as saying the probability of not getting A is given by the probability of 1 minus getting A, which you can also think about here in terms of this head and tail example. So if I knew in advance, for example, that the events of tossing a coin are complementary events, then if I knew that the probability of getting a tail is a half, then I can easily calculate the probability of getting a head. The probability of getting a head will be 1 minus the probability of getting a tail, which is 1 minus a half, which still yields the same answer. But I want you to also think about this case. The probability of getting a head must be the same as the probability of not getting a tail. Because if you get a head, that means you did not get a tail. So this is what this formula is trying to illustrate. So the probability of not getting A is equals to 1 minus the probability of getting A. All you have to do is to just remember these formulas. You don't really have to understand them fully at this point in time. Just remember that if you are given some two events and you are told that they are complementary, then this is what you have to think about. But in the exams, they will most likely ask you more about these two events, the mutually exclusive events or the mutually inclusive events. If they do ask you about this one, then I hope you will remember how to deal with them this way here. So for now, I will end this one on this part and call this part 1, the basics of probability theory. If you don't understand this, please watch the video over and over again until you fully understand this and try to come back and watch video 2 or part 2 of probability, where we'll be employing these formulas and trying to use them to solve problems as you would be asked in the exam. For now, goodbye.